class. Today we're going to talk about chapter 11, and we're going to learn to simplify some polynomials. So suppose we'd like to simplify here. We can only combine polynomials that are like terms. If polynomials are not like terms, we cannot combine those particular parts. So here we have 2r to the fifth. This has a variable r, and it's raised to the fifth power. Any term that will be like with that will also have r, and it will be raised to the exact same power, r to the fifth. Now the number in front, that's called the coefficient. That could be different. But in order to have a like term, it would have to have r, and it would have to be raised exactly to the fifth power. Okay, so do we see a like term for this one in this particular problem? Yes, I hope that we do. Minus 3r to the fifth. Also notice that 5r has a like term with 6r. So if we would like to simplify these, we'd do 2r to the fifth minus 3r to the fifth plus 5r plus 6r. Be careful when you move a term to collect it with its like terms that you move the sign with it. We do not move the 3r to the fifth and keep the positive sign. The positive sign belongs with the 5r. All right, so 2r to the fifth minus 3r to the fifth is equal to minus r to the fifth. You can think of r to the fifth as being like an apple. If I have 2 apples, but I promised Jane I'd give her 3 apples, and I give her all my apples, how many more apples do I still have, or how many do I still owe Jane? I still owe her 1 more apple, so owing 1 is like minus 1, and that's where I get the minus for in front here. Notice this is really minus 1 times r to the fifth, but in simplified form we don't typically write the 1. It's okay though in your scratch work, if it helps you to keep track, to write minus 1 r to the fifth, and then in your final answer just drop that 1 out. Because minus 1 times r to the fifth is minus r to the fifth. Plus 5r plus 6r. Well, if I have $5, pretend the r is $1, and I get another $6, then altogether I have $11. So my answer here would be minus r to the fifth plus 11r. And that is the answer. I point this out because many students are not sure you can stop here, but now we have r to the fifth and r. These are not like terms and cannot be added or subtracted. Since that is all we are doing in this problem is adding or subtracting, we cannot go any farther. All right, questions about this? If you have any, you can always send me an email. All right, now let's look at another type of problem that you'll see a lot. Subtract, and it's got a polynomial here, and then another polynomial there. This minus sign is instructing us to do something. It's saying, look, this minus applies not just to the first term, but to the second term and the third term, and if there were a million more terms, it applies to every single one of them. So when we subtract this, we get x squared minus x. Notice we just copy those first 2 terms down. Then minus, now we drop the parentheses, minus 2x squared. Minus times a minus is a plus, so that's plus 4x. And then minus times plus 7 is minus 7. Notice from this step with the parentheses to this step, we drop them because we have used up the parentheses when we multiplied the negative 1 times each of the 3 terms in there. Again, we write negative, but you may think of this as being negative 1 times all the things in here. And for many students, writing a 1 in here makes this possible to work correctly. And without the 1, they're just looking at it and they're really not sure what to do. So for your scratch work, it's fine to write a 1 in there if that helps, if it makes it make more sense. Let's collect like terms. When we subtract, it's implied that after that, we're going to simplify like we did in the last problem. We're not just going to subtract and then that's it. We always simplify at the end. In math, we're really big on simplifying. So here is x squared. Here is its like term, minus 2x squared. Here is minus x. Here is its like term, plus 4x. So when we combine like terms here, we get x squared minus 2x squared minus x plus 4x minus 7. So x squared minus 2x squared is minus x squared. Minus x plus 4x is plus 3x. And then we copy down the minus 7. And this is the answer. Again, x and x squared are not like like terms, so this and this cannot be combined. A number alone cannot be combined by adding or subtracting with a number that has an x, a term that has an x in it, or a term that has an x squared, so we cannot go any farther. Now there are two other ways that this problem might be asked, and I want to point them out because it's not obvious to most students that it's the same question. This same question might be asked as subtract, and then x squared minus x, 2x squared plus 4x plus 3. Notice there's not even a subtraction sign there because the book is expecting you to read the directions. When it says subtract, it's implied that you're going to add in the minus and the parentheses. Another way that students sometimes do not know what to do with this same question could be asked is find the difference when 2x squared plus 4x plus 3 is subtracted from x squared minus x. Notice that the subtracted from this is subtracted from that. That means that this x squared minus x, the thing that it's subtracted from, goes on top. And the 2x squared plus 4x plus 3 goes on the bottom. So this minus this could be said 2x squared minus 4x plus 7 is subtracted from x squared minus x. So be sure and note that this same type of problem can be asked more than one way. All right, excellent.